Alright folks, Phil Zito here, and welcome to day 3 of our BAS Bootcamp. So in day 1 we talked about BAS just overall. In day 2 we talked about inputs, and today in day 3 we're going to talk about outputs. So when we talk about outputs, there's really 4 kinds of outputs we're focused on. We're focused on internally sourced outputs, externally sourced outputs, and both of those are digital outputs. We'll talk about what that is in just a second. We're talking about voltage outputs, and we're talking about amperage outputs. Sure, there's other types of outputs. There's floating outputs, things like that, but ultimately floating outputs are just a version of internally sourced outputs where you use 2 of them. Alright, so what are outputs? First thing we need to talk about are the difference between relay outputs, which you can see right here, and universal outputs, which you can see right over here. So relay outputs, these have relays built inside, and they can actually open and close contacts to do what's called externally sourced output circuit closing and circuit opening. Basically what's happening is we can have voltage that is sourced through our outputs, right? And when this voltage goes into the output actually has a relay, and it will open up the relay to stop the voltage from flowing through, or it will go and close the relay to allow the voltage to source through. The downside of using relays internally is that if we are using internal relays and we get some form of voltage surge, then we are literally screwed. We're going to let the smoke out of our controller, as it's called, which basically means we're going to melt the motherboard, or at least blow the output. And that's not good. So that's why we typically recommend these things right here, which are known as relay in a box, right? So the relay in a box, the rib right here, is a actual relay in a box, and you can kind of see now that the autofocus is catching up that it has what's called a coil, and it has contacts. The coil is what gets energized by some voltage and then causes the contacts to change state. Okay, so the important thing to note here is going to be that when we are using these relays, one is that as we're using internal relays, we want to make sure that we are passing through the appropriate voltage rated for our contacts there, because if we're passing through like 120 and it's rated for 120 volts, we can actually destroy those. Also, we got to be cognizant of the amperage. Now that's for internal. When it's external, I mean, this thing right here, right, this relay in a box, once again, this thing costs like $10. So you blow a $10 relay in a box, it's not that big of a deal. You blow a $400, $600 controller, it is a big deal. That's why oftentimes when I'm first teaching my technicians and I'm like, hey, guys or gals, when you're doing actual control of contacts out in the field, maybe you're trying to pull in a coil or energize a coil for something out in the field, or maybe you're communicating power to something out in the field, I really recommend using relays. Now there's those relay in a box, as I mentioned, and as I showed yesterday, there are these IDEC relays up here, which these IDEC relays, right, those are simply just regular 2-pole regular relays, right, just normal relays. And if you're like, what is a pole, what is a coil, what is a contact, things like that, we're going to have an electrical video that we start to go through all this stuff, because I know yesterday we talked about shared commons and separate commons, and some of that stuff's not going to be familiar to you. Okay, so far we've talked about digital outputs. That's really what they're called, right? Internally sourced or externally sourced digital outputs. Then we have our voltage outputs, which are some of our more common outputs. One of the most common ones we're going to use is like this actuator right here, right? And so the actuator is quite simply going to utilize what is known as a analog signal. Now there are actuators that are going to use digital signals like open close. There's going to be actuators that use 2 digital signals like floating actuators. But this actuator right here, it's quite simple. It's just using a 0 to 10 volt DC signal, so that's direct current. If you don't know what alternating current and direct current is, don't worry. Once again, we're going to have an electrical session. I think we'll actually start the electrical session tomorrow. And I think what that will allow us to do is to start to dive through these things like voltage, current, amperage, power, and relays, and I think we'll dive through all that tomorrow. Okay, as I was saying though, we can see right here, right, this is an actuator, and what it's going to do is it's going to take a 0 to 10 volt DC signal from our controller, and it is then going to cause the actuator to open and shut. So other things that we'll use an actuator for are like dampers, where we want to connect to the damper and actually go and drive it open and closed. Valves, where we want to connect to the valve stem, drive it open and closed. But at the end of the day, I mean, there's really only 4 types of outputs that you're mainly going to deal with. Yes, there's pulse outputs. Yes, there's incremental or floating outputs. But the majority of the ones you're going to deal with are internally sourced, externally sourced voltage and current outputs. The thing with voltage or current outputs is we need to understand, are we using the same common? Now, I know we talked about shared commons, and I'm going to talk about this a little bit because we have about 3 minutes left in the video. But when I say shared commons, so on our controller, I'm going to pan over to it a little bit right here. On our controller, you can start to see, can you see the power? No, you can't see the power at that angle. Now you can see the power. You can see our 24 volts AC power right here, okay? And that power, it has a hot and a common. So the common returns to the transformer, which is right down here. You can see the transformer. Okay, so the common returns to the transformer, and that completes a circuit. So when we talk about a shared common, we talk about that this actuator over here, right? This actuator is using the same common, the same hot and common, the same circuit as this transformer that the controller is using. So if that's the case, then what can happen is we can actually just hop the common over from one of the outputs. We can hop the common over and just wire it directly into the terminal block because it's a shared common. Now, that's not what I recommend. I actually recommend that all I/O devices be on their own transformer. So we have a controller transformer and we have a transformer for I/O devices. This actually helps because if a single I/O device fails or like has a surge, what's going to happen is you're not going to lose your controller. You're just going to lose that circuit, and you can bring up another transformer for that circuit. Like this is down here, which I'm not going to pan down anymore, is a fusible transformer. It has a fuse in it, and if the transformer gets a surge of power, then we can go and replace the fuse and actually get the transformer up and running again. That's why I like this particular brand of transformers, plus the fact that it has receptacles and all that fun stuff. But when we're talking about power, when we're talking about outputs, just realize, and I'll show this in a future video, we have our internally sourced and externally sourced outputs. We have our voltage and our current outputs. I know I'm repeating myself again and again, but I'm doing that because I really want to get these terms in your head so that you're comfortable with this. Also realize that inside this controller we're going to have to set up our outputs, and I'll show you that in a future video where we actually go and set up our outputs. So if you have any questions at all, please post them below the video in the comments. I'd love to hear your questions, love to answer your questions, and I hope this is valuable for you. Thanks a ton, and I will see you in tomorrow's video where we'll start to dive into the electrical fundamentals.